Alright, so in this video we're going to be talking about solving two variable systems using the method called substitution. Okay, so in the last video we talked about solving systems by graphing, so you saw what solutions actually are. Okay, so remember that a solution to a system is where the graphs intersect. Okay, visually it's very easy to see that, but now we're going to focus on solving algebraically. Okay, but we always got to keep in mind that what we're actually finding is the point at which these two graphs intersect one another. Okay, now with substitution is best used when one of your equations, at least one of your equations, has a variable that is already solved for, or one of the variables can quickly be solved for. Okay, so in this particular example, if we look here, we have a system. We have y is equal to 2x plus 3 and negative 6x plus 5y is equal to negative 1. Okay, so as you can see, y is already solved for in this first equation. Okay, y is equal to 2x plus 3. That's a fact. Okay, in this particular system, y is definitely equal to 2x plus 3. So since we have y is equal to 2x plus 3, we can use substitution very quickly. Okay, so what I mean by that is that we can take what y is. Okay, y is 2x plus 3. That's how we can represent y. Y is 2x plus 3. And I can substitute it in for y in my other equation. Okay, so when we do this, what this is going to look like is I'm now going to have negative 6x. I'm substituting this into the second equation, so I'm going to have negative 6x plus 5y. Well, y is that quantity of 2x plus 3. Okay, y is that quantity of 2x plus 3. So I can take it and literally plug it right in for y in my other equation. Okay, so I have negative 6x plus 5y, this is y, 2x plus 3 is y, is equal to negative 1. And the reason we do this is because if you look now, everything is in terms of x. There's only one variable in this equation. And since we have that, we can quickly solve for x, okay? I can distribute this 5 to that quantity of 2x plus 3. So I'm going to have negative 6x plus 10x plus 15 is equal to negative 1. That's an equal sign. Equal to negative 1. That's a bad equal sign, but whatever. Okay, and now I have like terms on this side. I can go ahead and combine those. So negative 6x plus 10x is going to get me 4x. So I'm going to have 4x plus 15 is equal to negative 1. That's a better equal sign. That's a nice equal sign. All right, and now I can solve for x. All right, I have 4x plus 15. I can move the 15 over by subtracting each side by 15, okay? Because I'm going to have 4x, 15 minus 15 is 0, so that cancels out, is equal to negative 1 minus 15 is negative 16, okay? And that 4 is multiplying x, so to get rid of it, I can divide each side by 4. 4 divided by 4 is 1, so I'm going to have 1x, that's what I want, is equal to negative 4, okay? So I know that x is equal to negative 4. But remember, the solution is the point at which the graphs intersect. So my answer should be of the form x comma y. It's a point, okay? We know the x. We know that x is negative 4, but we haven't found the y, okay? So now what we have to do is we have to substitute in what we know, which is x, into either of these two equations, and that's going to help us find y. So I'm going to go ahead and take x is equal to negative 4. I'm going to substitute it into the first equation and solve for y. So I'm going to get y is equal to 2 times x. Well, remember, x is not 0. Why did I say 0? X is negative 4. Okay. Plus 3. Okay, so x was negative 4. So y equals 2 times x, which is negative 4 plus 3. That's going to get us y is equal to negative 8 plus 3, which gets us y is negative 5, okay? So our answer is going to be the point. It's the point at which they intersect, and the point at which the two graphs intersect is the point negative 4, negative 5. So this is going to be our answer, okay? All right, so I want to go over two more problems. So let's go over, let me scoot this over and cover a different problem. So let's say we had a system and it was negative 4x minus 6y is equal to 24 and x plus 3y is equal to -6, okay? Now, in this case, neither of the variables are solved for in either equation, okay? But if we take a look at this x right here, this x has a coefficient of 1, which means I can very quickly solve for this, okay? You can technically solve for any of these variables in either equation, but there's generally one or two that is going to be a bit easier, okay? And in this case, I can quickly solve for this x because it only has a coefficient of 1, which means I'm not going to have to divide by anything, okay? I just have to subtract 3y from each side. Which is going to get me x is equal to -3y minus 6, and now I have a variable solved for. So now I can go ahead and take what x is, and x is 3y minus 6, and I can substitute that in for x in my first equation, okay? That's what substitution is, getting a variable solved for and substituting it into a different equation, okay? So I'm going to go ahead and substitute that in. So this is going to be -4x, and x, as we see, is -3y minus 6, okay? And then minus 6y is equal to 24. And once again, as we can see, everything is in terms of y, which means we're going to be able to quickly solve for y. All right, so when we distribute this -4, we're going to have 12y plus 24 minus 6y is equal to 24. I have some like terms here. 12y minus 6y is 6y, so I have now 6y plus 24 is equal to 24. And now I got to solve for y. I can get rid of this plus 24 by subtracting 24 from each side. And once I get here, I'm going to have 6y. 24 minus 24 is 0. 24 minus 24 is 0. So I now have 6y is equal to 0. And for some reason, some people get a little concerned once they get to this. Oh no, I got a 0 on the other side. What do I do? Exactly what you would do if it's any other number, because 0 is just any other number, okay? If this was a 2, if this was an 8, if this was a 15, we would go ahead and keep solving by dividing each side by 0. Or excuse me, dividing each side by 6. Can't divide by 0. We would divide each side by 6 because 6 is multiplying y. So we still go ahead and do that. 6 divided by 6 is 1, so we have 1y is equal to 0 divided by 6 is 0, okay? That's all that means. Y is equal to 0, so don't freak out when we see a 0, okay? Think about it logically. So now we have y is 0, so I don't know what x is, but I know y is 0. But I know I can quickly find what y is. I can quickly find out, what x is by taking y and substituting it in for y to solve for x, okay? And that's exactly what I'm going to do. So I have x is equal to -3y. Well, we just found out that y is 0. So we have -3 times 0 minus 6. So we're going to have x is equal to 0 minus 6. So x is -6, okay? So our answer is going to be -6, all right? Now I just want to cover one more example, and this next example is actually going to be a special case, okay? Something different is going to happen with this one, all right? So bear with me. All right, so let's say we had the system 3x minus y is equal to 13, and 6x minus 2y is equal to 26, okay? Now, once again, neither variable is solved for in either equation, but I can quickly solve for y in the first equation because it just has a coefficient of -1, okay? So I'm not going to have to do too much work to solve for y here, all right? So I'm going to go ahead and subtract. 3x from each side. So that's going to give me -y is equal to -3x plus 13, and that is a -1 multiplying y. So now I have to divide each side by -1, okay? And that's going to get me y is equal to -3 divided by -1 is 3, so I'm going to have 3x. 13 divided by -1 is -13, okay? So I have y solved for now. I have a variable solved for. So just like before, I'm going to go ahead, I'm going to take what that variable is, in this case y, and y is 3x minus 13, and I'm going to substitute it in for y in my second equation, okay? So when I do that, I'm going to have 6x minus 2y. Well, in this case, y is 3x minus 13 is equal to 26. And I'm just going to go ahead and follow the steps just like before. I'm going to distribute that negative 2 in this case to get 6x minus 6x plus 26. I just distributed the negative 2 is equal to 26. And I have some like terms here. 6x minus 6x is 0. So my variables actually cancel out. And all I'm left with is 26 is equal to 26. And what we have here is one of our special cases, okay? What we have here is one of our special cases. Now, the only reason this happened is because all of our variables canceled out. All of our variables canceled out. So when all of our variables cancel out, one of two things can happen. One of two things can happen if all your variables cancel out. You can either have no solution, or you can have infinitely many solutions, okay? And this is only going to happen when all your variables cancel out, okay? If all your variables cancel out and you're left with a statement that is false, so 26 equals 26 is our statement. If that statement is false, we're going to have no solution. So like, let's say everything canceled out and we were left with 12 is equal to negative 37. That's simply not true. That would be a no solution. What that means is that what we actually have here is a pair of parallel lines that are never going to intersect, okay? Just like if you saw the graphing video, when you have a pair of parallel lines, that's going to be no solution, okay, because they will never intersect. So if all your variables cancel out and you're left with a statement that is false, that is a no solution. However, we're left with a statement that's true. 26 is in fact equal to 26. Well, what that means is that we have infinitely many solutions, all right? I kind of like to write IMS, infinitely many solutions, okay? And that's because if we were to actually graph these lines, they're the same line, okay? They're actually the same line on top of one another. So all the points on each line, because it is the same line, is going to be a solution. So that means infinitely many solutions, okay? So that is one of our special cases, all right? So in the next video, we're going to talk about solving systems via elimination, okay? So we talked about graphing, we talked about substitution. Next video, we're going to be doing elimination, all right? See you then.